Solar eclipses are one of the most amazing events in nature, a rare spectacle not able to be seen by many people, so it's not surprising that when one is due to be seen across America, a little hype builds up. Solar eclipses are caused when the moon passes between the Earth and the Sun, casting a shadow across Earth's surface. When viewed from Earth, people within the shadow experience an eclipse. Now, the moon can have eclipses too. Lunar eclipses happen when the moon passes into the Earth's shadow, and due to the way light passes through our atmosphere, leaves the moon a glowing red color. Solar eclipses also come in different variations, and to understand why, we need to first take a look at the moon's orbit. The moon takes around 27 days to orbit Earth, but even so, we do not experience eclipses on a monthly basis, and that's because the moon's orbit is tilted, about 5 degrees. Now, there are times when the moon crosses onto the same plane as the Earth and the Sun, and these points are called nodes. But nodes are only a part of an eclipse's story. The moon's actual orbital pattern is also a factor. The moon's orbit, just like the Earth's orbit around the Sun, is elliptical, meaning that at different times the moon will be at varying distances to Earth. This distance variation affects the moon's apparent diameter in the sky, meaning that the moon, depending on time, actually changes sizes in the sky, sometimes up to a 14% difference. This explains the difference between annular eclipses and total eclipses. During an annular eclipse, the moon is further away, or, in other terms, in or near its apogee, the furthest distance its orbit takes it from our planet. During this time, the moon will appear smaller in the sky, not big enough to fully occlude the sun's bright disk, leaving us with a nice but unsatisfying ring in the sky. Total eclipses happen when the moon is nearer to its perigee, or its closest orbital distance to Earth. This time, the moon is large enough to fully block out the sun, resulting in what we see. This is made possible by the fact that the sun, being roughly 400 times larger than the moon, is also roughly 400 times further away, giving both objects pretty much the same apparent size in our sky. Total solar eclipses are amazing to say the least, but in order to see one, there are other factors to consider. Even if you found yourself on the right time to view an eclipse, say August 21st, 2017, you still need to find yourself in the right place, because unlike its less picky cousin, the lunar eclipse, whose only requirement to be viewed is that you're on the Earth's night side at time of occurrence, solar eclipses are more finicky. Due to the nature of the moon's shadow, you really need to be in the right place if you want to see this eclipse, namely in the moon's umbra. For the upcoming eclipse, the umbra happens to be a 70-mile wide path cut across the United States. This is the path of totality. It is only in this swath that you can see the total eclipse. If you happen to find yourself in the moon's penumbra, outside the path of totality, you will only be viewing what's called a partial eclipse. But say you do find yourself in the path of totality on August 21st, what actually happens during a solar eclipse? And what can you really expect to see? Before continuing, it's really important to note that you must protect your eyes when viewing the eclipse. Use extreme caution. You can very easily buy a pair of eclipse glasses, but a new pair of eyes, not so much. The sun will damage your eyes, even during an eclipse. Okay, so assuming that there are no clouds nearby to block your view, this is what you can hope to see. A basic eclipse rundown. The event starts with what's called first contact, when the moon first touches the outline of the sun. The moon will appear as a dark disk and will begin to occlude the sun, slowly inching forward, growing larger and larger as time progresses. The sky by now will begin to dim as the sun shrinks even more until we reach second contact, marked by the onset of Bailey's beads, an effect caused by light passing through the moon's uneven terrain. Once the moon's shadow fully overtakes you, the sun will be covered, bringing the onset of totality. At this point, there are many things to look out for. During the brief period of totality, it will become safe to take off your glasses. Just make sure they're back on before totality is over. If you look up during this time, you'll be able to see the sun's corona, appearing as streaks of light stretching out from the dark lunar disk. The sky above will become dark enough that stars and planets will become visible, temporarily turning day into night. If you look around a bit more, you will see an orange glow painted across the narrow band along the horizon. This is the sun's light leaking through the atmosphere above from the areas outside the shadow, giving the effect of a literal 360-degree sunset. Totality during this 2017 eclipse is said to last an average of 2.5 minutes, but times will vary from location to location. Third contact marks the end of totality. The first ray of light from the darkened sun will begin to shine out again. From here on, the sun will only grow larger and larger, brighter and brighter. At fourth contact, the last sliver of the moon leaves the sun, and the eclipse is officially over.